So today we are going to look at linear equation method. So I hope you are ready for this. So we start with the step how to do this. But before that, if you have any questions, feel free to unmute yourself and then you can ask whatever questions. Okay, we start with this new method first, and then once we done with this method, we're going to look at few exercises. After that, we are going to discuss what we are going to do next week. Okay, we start with the step. Okay, so this method is called linear equation method. So any equation that follow this form, we call it as a linear equations. Okay, so you have, this is the differential equation that telling you that the equation is a differential equation. You have dy over dx, and then you have function y, and then you have some function gx. So gx can take whatever type of functions. So once you have this form of questions, you can set that your question is in first order differential equation, which is in linear form. So therefore, you can apply the next step. So to apply the next step, the first thing you need to make it in a standard form, which is given by this one. Okay, so if you look at your dy over dx, so in front of the dy over dx, we call it as a coefficient, which is the coefficient must be 1. Okay, so you need to make sure that in front of your dy over dx, the coefficient must be 1, and then y here. Okay, so in front of you y, you can have any type of functions. So it's represented by px. Px and the qx can represent any type of functions. But the dy and the x as well as the y, they must exist in front of your equations. So that's the first step. The second step would be you need to calculate the integrating factor. So this factor is given in this form. Okay, so you need to remember these equations. Okay, so you have exponent to the power of integration with this px is a function. So you get px from this function here. So after that, you multiply both sides of standard form with this integrating factor. Okay, so we will look at later during our exercises or examples. And then the fourth steps, the resulting equation in the left-hand side is equal to these equations. Okay, so this you need to remember as well. So it's equal to the derivative of your integrating factor multiply with your function y. And then finally, you integrate both sides of the equation and solve for y. So if you can represent in explicit form, so this would be the solution that you need to seek. All right, so that's the step. So now we start with the first example, and then we apply the step to solve this example. Okay, we consider this example as a linear equation. Okay, so you have this differential equation here, and then you have this differential equation here. Okay, so how you going to solve this? Okay, so you have two functions here. You have x3, and then you have y. Okay, so you need to split this into differentiation by parts because you have two different components. Okay, so the first one, we take x to the power of 3. Okay, so we make this as a constant value. Then you just differentiate function y. Okay, so we do it once at a time. Plus, now you differentiate x to the power of 3, then the function y remain. Okay, so this we call as differentiation by parts. So we have covered this in our previous discussions. And then this we call as a left-hand side of our equations. And then for the right-hand side, if you differentiate, okay, so this we call as the right-hand side of the equation. Okay, so you have x to the power of 3 dy over dx, And then you have 3x squared multiply y equal to 2. This equation you compare with the standard form, which is in your step number 1. So if you compare with the standard form, which is dy over dx plus px multiply y equal to qx. Okay, so it's not fit to the standard form yet because in front of your dy over dx, you're supposed to have a constant 1. So in here, dy over dx, inside your question, you have the coefficient x to the power of 3. So you need to get this to become 1. So how do you do this to become 1? Okay, so how do you make it to become 1? Divide with x to the power of 3, right? So if we want to make this to become 1, so we divide everything with x to the power of 3. So therefore, if you divide everything, so you have dy over dx, okay, so it's canceling each other, plus you get 3 to the power of x multiply y equal to 2 over x to the power of 3. Okay, so this is what so it should be matched with the standard form. Okay, so in front of your dy over dx, you have a constant 1. Okay, so once you done this, so you complete with your first step. Okay, so next you move to your second step. Okay, the second step required you to calculate integrating factor. Okay, so what is the variable for integrating factor is u. Okay, so this variable represent integrating factor. So it's equal to this equation, exponent to the power of integrating px dx. Okay, so you need to remember this. So what is your px here? What is your px?
3 over x.
Okay, 3
5.
over x. Okay, so this one, 3 over x, your px, because if you compare dengan the standard form, so anything in front of your function y is your px lah. Okay, so anything in front of your function y is your px. Okay, so put your px, you have exponent integrating 3 over x dx. Okay, so you need to integrate 3 over x. So how to integrate? 3 is a constant. You put constant outside the integrating factor. So you just integrate 1 over x dx. And then you will get exponent 3 ln x. Okay, so you can exclude the constancy in here. Okay, so you need to simplify this as simple as possible. Okay, since you have exponent here and then you have ln, you still can simplify this, but first you need to move constant 3 to become power of x. So you have exponent ln x to the power of 3, and then exponent and function ln will cancel. So finally you have x to the power of 3. So what is x to the power of 3 is your integrating factor. Okay, so this is your second step. Okay, so we're done with the second step. So the third step is we multiply both sides of standard form dE with the integrating factor. Okay, so which one is our standard form? The one that we have in our first step. So this would be our standard form, okay? The one that we have it in our first step. Okay, so we take our standard form dy over dx plus, okay, so we multiply everything with our integrating factor, which is x to the power of 3. Okay, so this will result in x to the power of 3. Okay, so find equation up to this stage. Okay, so this equation here we call as our left hand side of the equation, and this equation here we call as the right hand side of the equations. So if you read the step number 4, okay, so the step number 4 said The resulting equation in the left-hand side is equal to the derivative of your integrating factor multiplied with your function y. Okay, so your left-hand side simply become this. Okay, the integrating factor with respect of dx, okay, between two components, which is the first component is your integrating factor, which is x to the power of 3, and your second component is y. Okay, so it's directly will become this form. Okay, so it become this form. So if you expand this form, it become back up here. So it's just change the way you represent the equation. It's referred to the same equation, but we put in a more simple form. And for the right hand side of the equation, you just simplify as usual. So x to the power of 3 with x to the power of 3 will cancel each other. So you have 2. We're done with step 4. Now we go to step 5. So the step 5, we want to get rid of our differentiation here. So how you do that is we apply integration both sides of the equations. Okay, so when we apply integration, we want to get rid of the d over dx. Therefore, we integrate with respect of dx. Okay, so this will cancel. So you just left x to the power of 3 minus y. And then 2, if you integrate 2, 2 is constant. If you integrate, it becomes 2x plus constant c. Then you solve y. So your y would be 2x plus c divided by x to the power of 3. So finally, your y would be 2 over x squared plus c over x to the power of 3.
Doktor, mau
Yes.
tanya, apa jadi dengan tu 3x squared times y tidak dalam right hand side?
Tengok bila kita multiply, okay. So this one x to the power of 3, kita multiply dengan, okay, kita multiply dengan yang ini. Saya buat sini lah, okay. So dia x to the power of 3, kita multiply dy over dx plus 3 over x y. Okay, dia macam ni kan. So saya hanya represent dari bentuk macam ini, saya put it dalam bentuk yang lebih simple. So dia punya bentuk d over dx, x to the power of 3 multiply y. Okay. So dia jadi bentuk yang compact, bentuk yang simple. So kita hanya remember kenapa dia jadi macam ni, because if we multiply integrating factor, okay, so yang ini kita panggil integrating factor, and then kita multiply anything inside here, tapi yang ini make sure dia dalam bentuk standard form sudahlah. Okay, so anything that you multiply di sini, so dia mesti akan jadi dalam bentuk yang ini. Okay, dia bentuk integrating factor multiply dengan function y. So dia mesti akan jadi macam ni. So why is it? Okay, sebab kita ubah dia punya form dalam bentuk yang lebih compact. So macam mana kita tahu this is correct? Cuba kalau kita differentiate dia balik. Okay, so bila kita differentiate dia balik, dia akan jadi, first kita akan take x to the power of 3 constant. Okay, kita differentiate. Okay, so this is differentiation by parts lah. Plus we differentiate x to the power of 3, then y dia akan jadi constant. So, kita expand dia balik. So kamu akan dapat x to the power of 3, so dy over dx, plus yang ini if you differentiate, kamu akan dapat, kita akan dapat 3x square kan? Okay, 3x square multiply dengan y. Okay, kita akan dapat yang ini. Sekarang yang ini, adakah dia sama dengan yang ini? Okay, adakah dia sama? Okay, sekarang dia sama kan? So apa yang kita buat, kita hanya ubah dia punya bentuk dalam bentuk yang lebih compact. We call it as a compact lah. So bila kita apply linear equation dari bentuk yang lebih this one lebih panjang, okay, kita akan guna bentuk yang lebih simple. Dia akan jadi macam ni lah. Okay, so this is what happen bila kita move dari step number 3 pergi step number 4. So you just remember, okay, selepas kamu multiply dengan integrating factor, kita tengok step ni. So selepas kamu multiply dengan integrating factor, okay, multiply both side dengan integrating factor, so yang equation sebelah kiri mesti akan jadi in this form lah. So kenapa dia jadi macam tu? Because is compact your punya form. So kita verify di sini dia dalam bentuk yang sama lah. So actually what we do, kita hanya ubah dia dalam bentuk yang lebih simple because this is the step to solve using linear equation method. Okay, so in other words, you don't need to do anything here. Dari step 3 kepada step 4, so indirectly mesti akan jadi in this form lah. So that's why finding your integrating factor is very important. Okay, so okay with that. Okay, next kita tengok example 2. Okay, so hopefully you can understand better for this example. Okay, so this is our question. So if you look at your question, dia sudah di dalam bentuk linear form. Okay, sebab how do you know? You need to remember the linear form, so which is given dy over dx tambah px multiply y equal to qx. In front of your dx must be constant 1. So yang ini sudah match with the linear form, okay? So this is the standard linear form. Okay, so once dia match dengan standard linear form, then kamu boleh guna linear equation method. So next, the step is you need to find what is your px. Because dari px kita akan dapat kita punya integrating which is given by ux sama dengan exponent integration px dx. So what is kita punya px? Px adalah equal to this, right? Okay, so px this, so is equal to anything in front of your function y. Okay, so your px is, so masukkan 3 dx. Okay, so if you integrate 3, you got x, right? Because 3 is a constant, you put outside of the integration. So if you integration with 1, so you get x. So kamu akan dapat exponent 3x. Okay, so in here we exclude the constants. Okay, so this is kamu punya ux lah. Okay, so once kamu dapat ux, remember this ux, kita akan multiply ux yang sudah dalam bentuk standard form. So kita akan multiply exponent 3x dengan equation dy over dx tambah 3y. Yang ini untuk equation sebelah kiri. So we call it as a left hand side of the equation. And then sebelah kanan juga kita akan multiply dengan integrating factor. Okay, so yang ini kita akan panggil right hand side of the equation lah. Okay, so untuk yang left hand side of the equation, okay, so your step ni is very important. You need to remember for this part, you actually don't need to do anything. Kamu hanya perlu tahu dia akan jadi dalam bentuk yang simple. Form is, how does that form looks like, is given by this equation lah. So dia mesti akan jadi dalam bentuk derivative, okay, because kamu ada derivative di sini. So therefore dia akan jadi dalam bentuk derivative, okay, between two component. The first component is function y, because kamu ada y di sini, okay, so dia memang akan jadi function y. The second component is your integrating factor, your ux. So what is your ux is this one, your ux. So dia mesti akan jadi this, okay. So you don't need to do anything here. Kamu hanya perlu jadikan dia dalam this form untuk left hand side of the equation. Untuk right hand side of the equation, yang this one you can multiply as usual lah. Okay, so this one exponent 3x, if you multiply with this exponent negative 3x, they akan cancel each other, so you only left 2x. Okay, so any questions so far up to this stage? So now we want to get rid of this differentiation here. Okay, sebab kita mau solve untuk y. So untuk get rid, we integrate both sides with respect of dx lah. Okay, with respect of dx because we want to get rid of dx. Okay, so yang ini dia akan get rid of dx. So kita akan tinggal eksponen 3x multiply y. Untuk yang the right hand side of the equation, so if you integrate to x, so kamu akan dapat 2x square divided by 2 plus constant. Okay, so you simplify x square divide exponent 3x plus c divide exponent 3x. So this is your final answer lah. And we look example yang ada initial values. Okay, if you have initial value means you must be able to find what is your constants value. Okay, so we look example one is this example is you can try by yourself. Okay, we go for the difficult example, which is example 2. Okay, because this example is not in the standard form yet. Okay, so kalau kamu tengok example yang ni, dia bukan dalam bentuk standard form yet. Okay, the standard form must be in the form of dy over dx plus px multiply y dengan qx. Qx means whatever functions you have on the right hand side. Okay, so you need to get rid of your punya x in order to have it in a standard linear form. So untuk get rid of dia punya x, you need to divide everything by x. Okay, so this one you divide by x, this also you divide by x. Okay, so this will give you dy over dx plus 5y over x to 7x. This is what we want in the standard form. So yang ini in linear form, linear standard form. Okay, so next, once you get your linear standard form, so this is your px. Any function in front of your function y. So your px is 5 over x. Okay, so dari px, then you get your integrating factor, which is given by this equation. Okay, so just plug in apa kamu punya px, which is 5 over x dx. Okay, so as solve as usual. Okay, so 5 constant you can put outside the integrating factor. So you just integrate 1 over x, so kamu akan dapat 5 ln x. Okay, and then selepas tu 5 you move to become power of x because kamu mau get rid of exponent dengan ln. So x become the to the power of 5. So finally you have your ux equal to x to the power of 5. Okay, so the next step, you take this linear differential equation, multiply with this integrating factor. Okay, so dy over dx just now plus 5 over x multiply y. Okay, so yang ini the whole equation kita multiply dengan x to the power of 5. And then untuk sebelah kanan you have 7x. Okay, so x to the power of 5 multiply dengan 7x. Okay, so this kita panggil left hand side of the equation, and this one we call right hand side of the equation. Okay, remember untuk left hand side dia akan ubah dalam bentuk compact, which is the differentiation between two components. Okay, so the first one is your integrating factor, which is x to the power of 5. And then the second component is your function y. Untuk right hand side, yang ini you multiply as usual. So give you 7x to the power of 6. Okay, now we want to get rid of this differentiation. Therefore, we integrate both sides of the equations. Okay, so untuk yang left hand side punya equation simply become x to the power of 5 minus y. Untuk yang sebelah kanan, okay, 7 is a constant you can put outside. So what you differentiate is, what you integrate is x to the power of 6. So dia akan jadi x to the power of 7 divided by 7. And then plus constant c lah. Okay, so you simplify this. And then x to the power of 5, you move to the other side. Okay, then you get for your y. Okay, so this one you get y x to the power of 7 divide x to the power of 5. So it's same like 7 minus 5 lah. Okay, so you get this final answers. Now we put our initial values. So this initial values tells you that bila kamu punya x is equal to 2, then you get y equal to 5. So masukkan y equal to 5, x equal to 2. Okay, so later on you can solve it to get your C. Okay, so this one I leave it to you lah. Okay, so initial value means when you plug in the values x and y, you should be able to solve your constancy. Then the constancy you just put back in your solution y. Okay, so far so good. Any questions?